All right, let's talk about the journey that pretty much every piece of software takes these days. We're going from lines of code on a developer's laptop all the way to a powerful app running out there in the cloud. Now, this path can be full of headaches, for sure, but it also has some seriously cool and elegant solutions.
So picture this. You've done it. You poured hours, maybe days, into getting your application just right. And it works. It runs beautifully on your machine. But that's just step one, right? The real goal is to get it out into the world for people to actually use. And that, my friends, is where the real adventure begins.
And almost immediately, you hit that classic, infamous wall. We've all been there. You hand your code over to a teammate, or you try to push it to a server, and it just breaks. It completely falls apart. And why? Because their computer, their environment, is different from yours. They have different libraries, a different OS version, you name it. It's a total nightmare.
So, the dream, the ultimate goal here, is to solve this problem once and for all. We need a way to package up our software so that it runs predictably, reliably, every single time, no matter where it is. And not just that, it needs to be able to handle one user just as well as it handles 1 million users.
For years and years, the standard solution for this was the virtual machine, or VM. Just think of it as an entire computer, the operating system, everything, simulated in software. So you'd pack your app inside its own VM. And yeah, it works, but it is some serious overkill. It's like using a giant sledgehammer to hang a tiny picture frame. It gets the job done, but wow, is it heavy and inefficient?
And that brings us to a much more modern, lightweight, and frankly, smarter approach: containers. They solve the exact same problem that VMs do, but they do it in a way more elegant fashion.
And this right here is the core philosophy. It's asking, instead of packing and shipping a whole computer, what if we just pack the app and only the essential bits and pieces it needs to run? That's a container. It's a perfectly tailored, self-contained little box that holds your app and nothing more.
When you actually look at them side by side, the difference in efficiency is just staggering. A VM has to boot up a whole operating system, which can take minutes. A container, it's up and running in seconds. And because it just shares the operating system of the machine it's on, its resource use is incredibly low. This is a complete game changer when it comes to speed and cost.
So how do you actually make one of these? Well, it's a pretty simple 4-step journey. You start, of course, with your code. Then you write a simple text file called a Docker file. Think of it as a recipe that lists the ingredients for your package. That recipe builds an image, which is kind of like a static blueprint or a snapshot of your app. And finally, when you run that image, poof, you get a container. That's your app, live and running.
Okay, great. So we've solved the packaging problem. Our app is neatly tucked into a container, it's portable, it's ready to go. But what happens when your app is a huge success? Now you don't just need one container, you need hundreds, maybe thousands, all running on a whole bunch of different machines. How in the world do you manage that kind of complexity?
Exactly. How do you make sure your app is always online, even if one of the servers crashes? How do you automatically add more containers when traffic goes through the roof, and then get rid of them when things quiet down? And how do you update your app without your users ever noticing? Trying to do all of that manually is, well, it's just not possible.
And that is precisely where Kubernetes comes into the picture. It is the master orchestrator. I love this analogy. It's the conductor for your container orchestra. You don't tell every single container what to do. No, you just hand Kubernetes the sheet music. You describe what you want to happen, and Kubernetes handles all the complex details of making it a reality and keeping it that way.
And this is really the magic of it. Kubernetes automates all the hard parts. If a container crashes, Kubernetes just replaces it automatically. That's self-healing. If you get a huge surge in traffic, it just adds more containers. That's horizontal scaling. It handles all the complicated networking and lets you do updates seamlessly, all without you having to lift a finger.
So, how do we tell our conductor what music to play? Well, we don't just yell commands at it. Instead, we give it a set of blueprints. These are just simple files that describe the desired end result we're looking for.
The most basic, fundamental blueprint in the Kubernetes world is for a pod. Honestly, the best way to think of a pod is just as a little house that our container lives inside. It's the smallest individual thing that Kubernetes knows how to manage. But here's the thing. We almost never create those pods one by one. Instead, we use a much more powerful blueprint called a deployment. A deployment is where you can say something like, "Hey, Kubernetes, I want you to make sure there are always 3 identical copies of my app's pods running, at all times. Kubernetes then takes that order and makes sure it's always true, creating the pods and watching over them 24/7.
Okay, we're at the final piece of the puzzle. Most real-world applications aren't just one single thing, right? They usually have multiple parts. You've got a front end that the users see and a back end that does all the hard work, and they have to be able to talk to each other. But in the super dynamic world of Kubernetes, that's not quite as simple as it sounds.
Remember how Kubernetes is always destroying and creating pods to heal itself or to scale up and down? Well, every single time a new pod is created, it gets a brand new, unique network address, its IP address. So behind the scenes, you have this constantly shifting landscape of addresses.
So if the addresses of the back-end pods are changing all the time, how can the front end possibly know where to send its requests? It's like trying to call a friend whose phone number changes every 5 minutes. You just can't do it.
The solution is another brilliant Kubernetes blueprint, the service. What a service does is it creates a single, stable network address that never changes. It sits right in front of a whole group of your backend pods and basically acts as a reliable middleman.
And this is the absolute key. The front-end app no longer tries to talk to those chaotic, constantly changing pods directly. No, it just talks to the calm, stable service. The service then takes that request and intelligently routes it to a healthy back-end pod that's ready to work. It makes the whole communication process stable and super reliable. So let's just quickly recap the whole journey we just took. We started with our idea, which was just our code. We solved that classic "it works on my machine" problem by packaging it all up into a portable container. And finally, we used Kubernetes to scale it, make it resilient, and connect all the different pieces together. And there you have it. What started out as just a file on your computer is now a fully robust, professional-grade application. It's capable of serving users all around the world. It can heal itself if something goes wrong, and it can scale up or down whenever it needs to, automatically.
You've basically just unlocked the blueprint for how all modern software is deployed. So the only question that's left is, with all this power at your fingertips, what incredible idea are you going to bring to life next?